This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Good day to you all, and welcome to the tutorial Introduction to GIS for Retail Locational Analysis. This tutorial will introduce some of the key concepts of GIS and the functionalities of QGIS and how these could be applied in site suitability analysis for retail property based on the gravity model as part of the course Land and Property Economics for this semester. My name is Godwin. What you would find out in this session is that while it is 1 hour, I have broken up the video into chunks. This is meant to help in finding out specific parts of the video that address or demonstrate specific concepts and functionalities of GIS. All the data that is used for the tutorial is also available to you on the LMS. Now let's move straight to the outlook. So in this tutorial, we'll be looking at vector data types and how to import data into QGIS. And the main software that we are using today is QGIS. Creating layers in QGIS or shapefiles in QGIS from Excel data. Merging such data with shapefiles. Projecting coordinate systems. Measuring the distances automatically. Selecting features based on attributes. Exporting attributes of shapefiles. We'll also take a look at importing scores on the SA2 statistical area 2 of the ABS into QGIS, and finally we'll look at creating some heat maps and exporting maps out of QGIS to other platforms or for sharing and distribution. So before moving on to QGIS, what is vector data? And this is an essential This is essential for our tutorial today because the data we'll be using primarily would be vector data and some Excel data as well. So every location, physical location on Earth can be represented by pairs of longitudes and latitudes. And so if you look here on the left, I have the map of Australia. And so which means that the location Melbourne, for example, which is here, would be located on your longitude 37, about 37, and your latitude, let me see, yeah, so your latitude would be around 37 and your longitude would be around 45. So these longitudes and latitudes, it would represent the location of Melbourne, and that goes for all the other cities and every other location, that physical location that one wants to represent on a map. So point data, which is a type of vector data, then is a representation of a location with a single pair of longitude and latitude, as I have demonstrated with Melbourne. And these points, of course, are non-dimensional, so which means that you cannot measure distances or length. Now, lines represent multiple pairs of longitudes and latitude which have been connected or joined, and therefore they represent linear features such as roads, rivers, railways, and so on. Now, polygons also consist of multiple pairs of points, but in this case, the first and the last coordinate pair are exactly the same. In this case, then you have your polyline being enclosed into a circle or a loop. Now, such features or such data can be used to represent census districts, the outlines of buildings, or the outlines of countries. So, for example, you can have the representation of Australia, and that would be a polygon. So now let's move straight to QGIS. So here I have my QGIS already launched. I am using version 3.20. Feel free to use any version that you feel confident with. I am also assuming that you have QGIS already installed on your various devices. If you do not have QGIS already installed, you can follow the guidelines provided on LMS as part of this tutorial. So upon opening QGIS, you will of course notice your menu bars and then your standard toolbars here, and then you have your panels. So I have my browser panel and my layers panel also selected, and then my map view. So if you do not have these panels, or you have multiple panels, but you want to have a cleaner interface, you can go to your menu toolbars and click on view, scroll down to panels, and ensure that your browser and your layers are checked, and then you can uncheck any other panel that you do not wish to be displayed. So setting up, let's set up our new project for the tutorial. So to do that, go to the menu bar again, toolbar again, and click on project, and click on, and scroll down and click on properties. Now here, the primary function that we want to set is the coordinate reference system, CRS. So you click on CRS, and we are looking for the coordinate system GDA 94. So this is the coordinate system that the data that we are using already comes in. So more on coordinate systems later, but every GIS or spatial data that you would retrieve, especially from Australia, already has a coordinate system specified. And so in this case, I already have GDA 94 here, which is the geocentric datum of Australia 94, and 94 is the year that this was specified. If you don't have this, you can quickly just search in the filter. If you type GDA 94, it would show here, and then you can scroll down and find it here. You can see GDA 94, and of course we are using the 4298 83 EPSG. So if you click on it, so in my case I click on it, and then you click on apply and OK. Now this makes sure that any other data all the data that we are bringing into QGIS aligns with this coordinate system. So the next to do is, of course, to bring in the data that we already have on the LMS. Now, please note that these data sets are subsets of publicly available data. The sources are already indicated. And these were modified to ensure that the data loads pretty fast, because this is an online tutorial and geo processing is quick. So note that if subsequently you are using larger data sets or special data, the processing might not be that fast depending on the specs of your laptop or your desktop, and you can even have situations where your QGIS may hang or become unresponsive. So in the browser panel here is where we would use to import our data into QGIS. So here, under here, you will navigate to where your data is saved on your device. So in my case, I click on my C drive, users. So the data set consists of different shape files and primarily vector data of the boundary of Victoria, Greater Melbourne. This is based on the statistical area 2, and train stations. And so first, we would want to bring in our map of Greater Melbourne. And as I mentioned earlier on, This is to make sure that the data runs fast on an online tutorial, and also ensure that when we are subsequently doing our geoprocessing, that of course we do not run into GIS being unresponsive. So to bring in our data is simply to click and drag into the layers panel. And here we have our map of Greater Melbourne, and every location here represents a statistical area too. And this is the basis for collecting or aggregating population census data on, I mean, the population census data is aggregated on different levels, and statistical area 2 is one of them, with the smallest being the statistical area 1. So with this, we have our map to see the data behind this map. We simply right click on the layer and click on open attribute table. And now, of course, we've opened the attribute table. You have our the codes for the various areas, their name, respective names, state codes. The state name is Victoria, and of course, and then the area in square kilometers for each statistical area. And of course, you can notice that the areas of the statistical areas are pretty consistent and range from about 2 or 1 to 10. Okay, I see 20 here too, which is probably the largest. So this is how you view the data behind your shapefile in your layers panel. Now let's bring in the other data boundary. So this is the boundary for Victoria. Now you notice that when you bring in your boundary for Victoria, it overlays or it overshadows the initial shapefile for the Greater Melbourne, and this is because of the visibility protocols of QGIS, such that it should be arranged in order where point this data is first, then you have lines, and you have polygons. So we can drag our Greater Melbourne above our Victoria. Of course, both of them are polygons, but the Greater Melbourne is smaller. Finally, let's bring in our transport data. So our train stations, and these are points. And you would notice that the the color coding makes it difficult to see the train stations. Let's drag the train stations above. Okay, excellent. So you can see it, but of course you can always change the colors and make this look nicer. So to do that, let's right click on Victoria, click on properties, and then click and then scroll here and then click on symbology. Now we can change the infill color. We don't want it to be solid. So we can make the fill color. Okay, we can even, let me take this off. We don't want it to be solid, and then click on apply. And we do this because the map of Victoria is not the focus of the exercise today. And so we have here, so this is the boundary of Victoria. We have our Greater Melbourne, and we have our train stations. Now let's also import the data for transport routes. So in a similar vein, you would navigate to where your roads data is saved, and simply drag and drop, and make sure that order is the same. So the order should be points, lines or polylines, and polygons. And so you see that here, because our lines is beneath our polygons, the lines do not show, or the transport routes do not show within the Greater Melbourne. So when you simply drag, and then we can see it. Now you can notice that the colors also make it a bit difficult to see. So you can quickly right click on the roads properties and click on symbology. This already selected here. Click on color, and let's change the color to something which would be better visible. I think I should choose something closer to red. Yeah, apply. Now, of course, you can always change the colors as often as you want to ensure that the colors that you have are satisfactory to you. But there are also standard colors for different land uses, and you can check that up on the Victorian government website, the planning website. I think this is okay. Let's change the symbology for the train stations. Train stations, right click, properties, uh, simple marker, scroll down. I think we could make them change the kind of shape you want it to look like, and then let's change the color to hmm, let's see. Yeah, that looks better. So here we go. So this is how to import different uh, vector data into QGIS. Well, what I often like to do is that to give the map a better context is to import a raster data, that is the open street maps, to better make it align and give some context to where this particular map is located. And to do that, you just go back to your browser, scroll down, you find OpenStreetMaps here. You drag and drop. It will ask you to specify your coordinate systems. And I said we'll talk about coordinate systems in a bit, some details. Click on the first option, that is your. Now this is because the coordinate system of our maps are in GDA 94, but the coordinate system of the OpenStreetMaps is in VGS 84. Click on OK. And the same way, so raster data should always be at the bottom of your map. Okay. And so when you zoom out, you can see some better context. Okay, it's taking a bit of time to load, but you can already see Tasmania here, and then you can see New South Wales, Victoria. Okay, we have to be a bit patient. Okay, here you go. So here you go. So you have your map of Australia, giving a better context, and then you have your Victoria and the other territories and states. And of course, if you zoom out, it's OpenStreetMaps is a global map, so you can see all the other areas around the globe. But our interest, of course, is uh, Australia and Greater Melbourne to be specific. So if your coding systems are wrong or are not exactly the same and you do not transform, then you will have a situation where maps are misaligned. So this is primarily how to import data into QGIS. Next, we'll look at how to import Excel data into QGIS and merge that data with existing shape files, and also how to create shapes files or layers based on the Excel data that we will import. So occasionally you have some data sets that you retrieve from public sources, which is not geographic information. So, for example, you obtain data on population or some socio-economic indicators, number of households in a particular location, or vehicular population, uh, population of animal species, or population of specific land uses respective to different locations. Now, this such data might not be geographic in the form of shape files, but in a form of a spreadsheet. Now, how do you bring that data into QGIS? I think I would like to improve the transparency of my map of Greater Melbourne so that we can see beneath that. So to improve, before we go to importing data, let's uh, reduce the transparency or increase the transparency of our map so that we can see through to the OpenStreetMap. So right click properties, and under opacity you can see some symbology is already selected. Opacity, let's change this to 50%. Apply. Okay, that looks better. Okay, so you can now see beneath the map. So to import our Excel data, first always remember that you have to save your Excel data as a CSV file, a comma separated values file, and you inspect your data to see what is the content of that data. In the case of this exercise, we have, of course, our data, our shape files for Greater Melbourne, as you will see here, but we do not have any data on population or any other variable or factor that would be of interest. And what we are trying to demonstrate is how to bring in population data and join that with the existing uh, data on the SA2. So first, you should always examine the data and see what factors are there, what variables are captured, what is the nature of the data. So let me bring it in here. And you can see here, of course, that so this is also publicly available, the source is indicated, but this is specifically extracted for Greater Melbourne. So you see here we have different codes. These are explained by the ABS, and we have our SA2 code, the names of the particular locations or districts, estimated populations as at 30th June 2020. We have net overseas migration, we have area, and then population density. So these would be of interest. Of course, you don't have to import all of it, but one thing you should always notice that you need a unique identifier which is common to both your spreadsheet or your CSV file and the data in your shapefile in QGIS. So if you go back to our attributes table, you'll notice here we have your SA2 main, which are codes, and these codes are unique. So each location has a specific code. So this would be the basis for joining the CSV data with the shapefile data or the attributes of the shapefile. Now, if you have a case where you do not have any unique identifier, then it's practically impossible to link your CSV data to GIS unless, for example, you the data sets you are interested in just bringing in the data, and there are no specific layers. Sorry, there are no specific features that have specific data. So, for example, let's say you wanted to bring in state codes, and state codes is the same for all the features for this particular SA2 for Greater Melbourne. So then in that case, it doesn't matter. But you have data which is specific to each feature, then of course you need a unique identifier. So this will be the basis for our joining. So we can close this. And first we need to bring in that data also into the layers panel. as well. So scroll and to your browser panel and locate where your data is saved. Users in my case. So I have my population data here, and exactly the same data that I showed here. So we would bring this into GIS. And of course, once you bring that in, nothing shows on the map view because this data has no spatial properties. It has no coordinates, longitudes and latitudes. Now to merge this data with our Greater Melbourne, we'll right click and click on properties. And then we would scroll to join. Let's find join here. So, joins. Excellent. Now on clicking joins, we'll click on the plus sign here at the bottom. Add new join. And then we have our Greater Melbourne. Now we need to specify the fields that we want to join. In this case, so we have, let's go back. The basis of the join will be the SA2 code. Yeah, SA2 code. So join field SA2 code. And the target, of course, is also the unique identifier for our layer, Greater Melbourne, and which is SA2 main. And this is visible, of course, from the attribute table. Now we can click here, join fields, and select whether you want to import all the values from the Excel table, Excel, or you want specific. So in this case, some of these things are not necessary for our purposes today. So for example, SA3 name and SA2 name and so on. What we'll be interested in would be the estimated population. So you make sure that is checked. Overseas net migration and population density. After clicking all of that, nothing else, leave everything as default and click on OK. Then click on apply and OK. Now what happens is if you now right click on your Melbourne, Greater Melbourne, and go to attribute table, you will then see that data that we just joined. So we have our uh, estimated population of Greater Melbourne as at 2020 here. You have your net overseas migration, and then you have your population density. Now, after joining, of course, if you can remove. Now, the best, I mean, good practice would be that after joining your data sets, you export this shapefile to have the new data. So to export the new shapefile with the new data, we right click on export, and click on save features as. So the format you can export, you can always export QGIS data in various formats. But what you're interested in here is the ESRI shapefile. You can give it a name, but let's navigate to where we would like to save this. So create a new folder if you want to, and say Greater Melbourne. SA2, there's a new. And then of course we give it a name. So Greater Melbourne with population. Let's add population to it. Save. And then your coordinate system, make sure that it is the same coordinate system that we used for the maps. Everything else remains as default. And then you click on, make sure that this is also selected, add saved file to map, and OK. Now once you do that, we now have a new layer with the data. And of course, we can then remove these ones because they are no longer necessary. Remove layer, and then remove the old one. And then of course, now when you right click on your Greater Melbourne with your population data, you would have exactly what we're looking for. So you have your population, your net migration, and of course, um, now what has happened is that the names of fields cannot have spaces. That's what has happened. Cannot have spaces. So that's why you see these things here. So this is your net migration, and this is your population density. We can change this later on into names that are more recognizable. So this is how to import, of course, so your Excel data into QGIS and merge it with existing data in your QGIS. And now we can, for example, display this data shapefile of Greater Melbourne based on population or any other variable that is of interest. So let's see how we can bring in our shopping center data. So of course, it's important to have a look at this shopping center data and see what kind of data that is. Sorry. We can close this now. I think I have my shopping data already opened. So this is also specific to Greater Melbourne. But if you look here, this data, okay, you have all the data about the shopping centers, but what is key here is that this data has geographic information. So if you scroll to the tail end, see that the locations of each shopping center is specified in longitudes and latitudes. So which means that we can represent this or create shapefiles out of such information as points, of course, because each shopping center is represented by a single pair of longitudes and latitudes. So we can close this and then go back to QGIS. Now to import that, now since we are interested in creating shape files or geographic information out of this data, the process is different from importing just a regular CSV or Excel file without any geographic information and merging or joining that to existing layers. So to do that, the process would be to click on layer and add new layer. Scroll to add new layer, and then in here we will be adding add delimited text layer. Now recall, as I mentioned, that every data that you want to bring into QGIS, for example, if it's in Excel, you should always convert it into CSV before you bring it into Excel. And then we would select our file by navigating to where the data is located, shopping center, open. Let me extend this a bit more. So we can still leave the name as shopping Melbourne, leave encoding as the same. For file format CSV, uh, text file types, first row has field names, this is correct. Then scroll down. Now the points here, it already automatically detected that the data in your file had coordinates and has already pre-selected that. So you can see that your geocode longitude is your X coordinate and your Y is your latitude. You do not need to change anything else. What you also need to be mindful is the coding system, which should be, now we can change this to what we already use, which is the GDA 94, because that is the coding system of the entire map. Everything else, leave it as uh, default. Click on add and click on close. And here, of course, we should bring this up. Excellent. And I can see that our green little circles are our shopping centers. and these have been added to the map. If you right click on the shopping Melbourne and go to attribute table, you'll see the entire data set that we just brought in. So you have your type of shopping mall, regions, sub-regions, addresses. The entire spreadsheet has been brought into your QGIS. So of course we can manipulate this by labeling some of the shopping centers. We can change the colors and the symbology and so on and so forth. So next, let's see how we can measure distances. Let's see how we can measure distances. So whether there's are distances from shopping centers to train stations or from shopping centers to roads and so on and so forth. So before we proceed to measuring our distances, let me just demonstrate how to change the names of our fields in the attribute table. Remember that or recall that we have here our population one, which was the net migration, population of net migration, and population two being our population density. So to do that, and make it more intuitive, you would click on processing, toolbox, scroll to toolbox, and in your processing toolbox, let's look for the function rename field. Okay, rename field, sorry here. So and double click on it. And what we are trying to rename, of course, and this is how to rename any fields in your attribute table. So you select the layer that you on which you want to rename. So that was the Greater Melbourne SA2. Now what we wanted to rename is population 1. And then we give it a new name. So net population net migration. Let's say net migration. Okay. Everything else is left as default, and then you click on run. Close. Now once you do that, QGIS automatically creates a new layer with your new information. So if you, and that's what we have here as renamed. So if you click on rename, go to your attribute table, then we will have our population one now renamed to net migration. So this is how to rename any of these fields if you want to have a more intuitive name. But yeah, this was just for demonstration. We will not proceed to rename the rest, and we'll remove this from our, our layers. So remove, remove, and okay. So how do you measure? How does one measure distances? So for example, you want to measure the distance between, let's say, let's reduce the transparency, improve the transparency so that we can see beneath. So symbology, opacity, let's make it 50%. Let's make it 40. Apply and okay. So that you can see beneath the map. So you see here that we have our roads, and you probably want to find out the distance between, for example, this shopping center to the road. There are different ways of doing this, and I'm going to demonstrate three of them. So if this is just a quick one you want to do, you would click on your measuring tool here. And you can just click on the feature to the distance that you're interested in. And when you click, you can right click and then you have it. And it tells you that this is in, we can even change it to kilometers. This is about 9 kilometers. So from this shopping center to this road. And there's a difference between ellipsoidal and Cartesian. So Cartesian is measuring the distances on a flat Earth, and ellipsoidal is measuring the distances on a spherical Earth. And if you select any of them, the differences will be the distance will be different depending on whether the distance is being measured, as I mentioned, on a flat Earth or on a spherical Earth. And so this is how to measure distances, quick distances. If you just want to, if you just want to see how far away one feature, one property, or one shopping center is to another uh, physical location. The next one to do is to use your buffers. And to do buffers, so you would buffer to see, for example, what is the coverage area of a shopping center. At this point, let me deactivate strains. And for example, we want to see how far away is this shopping. If somebody was living 2 kilometers away from this shopping center, would they be able to access the shopping center? Or how far away should somebody be if they had to drive, let's say, 10 minutes or 15 minutes to access the shopping center? This is where buffers come in. And you want to see how concentrated the shopping centers are at one place and how many people can access particular shopping centers or particular land uses. So the simple process is to, of course, go to your vector toolbar because we are analyzing vectors, and go to geoprocessing tools and click on buffer. So input layer would be the layer that contains the features that you want to create your buffers around. Now you can also create buffers around specific shopping centers or all shopping centers. So you would select your and this procedure is to create buffers around all shopping centers. So you would select your input layer, let's say shopping Melbourne. Now what you notice is that your distance is in degrees. Distances measured here are in degrees, and degrees are not intuitive. They are measured in degrees because of the geographic coordinate system that we selected, GDA 94. Now geographic coordinate systems measure or define the physical locations of Earth based on degrees, relate that to a prime meridian, which is your longitude 0, and your datum. And your datum defines the location or the position of that particular location relative to the Earth center. I have provided enough additional information to further the understanding of coordinate systems on the LMS. But for this particular purpose, if you have geographic coordinate systems, remember that your distances will be measured in degrees, which are not intuitive. For example, 1 degree is 111 kilometers. And so if you wanted to measure 1 kilometer buffer around a particular shopping center, that will be 0.01. And that is not very intuitive. So what we want to do is to convert this into units which are more intuitive. I mean, if somebody is confident with measuring distances in degrees, that's fine. They don't know how to do anything else. They can just proceed. But if I'm interested in measuring distances in using metrics that are more intuitive or convenient, we have to change this coordinate system, which is the GDA 94, into a projected coordinate system. Now, what a projected coordinate system does is to convert your geographic coordinate system into um, Cartesian coordinates, so into x and y, and then you can then measure distances there with either meters or kilometers or any other metrics. Okay, so to do that, we would need to export our shopping center layer into a projected coordinate system, and this is what it meant by projecting coordinate systems. So you simply click on shopping Melbourne, right click, and click on export features. Here we can navigate to a folder and save our new layer. So let me navigate, create a new folder and let's call it shopping centers new. And in here we can give it a new name. Let's say shopping UTM 55. 55 So this is the projected coordinate system for Melbourne. Now we need to select the desired coordinate system of interest. So you can click on this. Okay. And then, so the projected coordinate system that we would use for this exercise is the UTM zone 55 south. If you cannot find it, I already have it here, but if you cannot find it, you can simply search for it, UTM zone 55 south, and then you can find it here. And then we are using the VGS 84 slash UTM zone 55 south. So you click on it, and then it shows you the region where this particular coordinate system is applicable by the, let's say, pink rectangle. So it means that if this map was for Perth, this coordinate system will not be the same. It might be a different zone. So click on OK. Let me extend this a bit. So everything remains default. Make sure that you click on the Add Saved File to Map, and then we click on OK. Now, what's the difference? Now we have a new layer with UTM zone 55 south, and this is what we saved our new shape file with. Now, if you click on Properties, you would notice here that the coordinate system has changed, and then the units is in meters. Now compare this to the previous one, and you'll notice that the coordinate system was GDA 95, and the units were geographic. So this is in degrees. And therefore, if we want to create buffers with this, we can measure the distances in either meters or kilometers. So we can remove this because we know it's no longer needed for the exercise. So remove. Now be mindful that I in preparing this tutorial, I encountered a challenge where the some of the coordinate systems, some of the coordinates for the shopping centers in the Excel were empty. So if you have empty coordinates, or in a case where the coordinates are missing, you have to delete those ones. Otherwise, it will give you challenges if you are projecting from one coordinate system to another coordinate system. So let's create a buffers. So first, you can create a buffers for just one or a group of shopping centers. So for example, you can create a shopping buffers for, let's say, these two shopping centers here, or you can create buffers for the entire database, the entire all the shopping centers. So let's demonstrate first how to create buffers for just one or two shopping centers. To do that, first you need to select those shopping centers. Now you can just select by, if for example, using your select tool, and then you draw it over the features that you want to select, and it will select them. You can select this one, and then when you click on this, you will deselect. This is to deselect. This is to deselect features. So select, and then we can now create our buffer for this to see what is the coverage of this shopping center. So go to buffer on the menu bar, toolbar, go to geoprocessing tools and click on buffer. Same process. Now you will see that our shopping center is selected, but also our units are no longer in degrees by meters, and you can change this to other forms, so kilometers or miles. Let's use kilometers and see if somebody was if somebody was 10 kilometers away from the shopping center, how far away, I mean, what distance would they have to cover? So we can leave all the other the settings to the default and click on run. Oh, okay, there was a mistake. Let me remove this and let's do it again. Buffer. Uh, shopping. We need to select the selected features only. Otherwise, it's going to buffer for everything. So that's why we did not check earlier on. So kilometers and everything else remains default. Then click on run. Now let's remove the initial one that we did. But that's of course the process for doing the buffers for all your shopping centers. Remove from layer, and then we can bring our shopping centers on top. And you can see that let's even increase the opacity by going to symbology and reducing this to make it more transparent. So let's say 50. And so you can see that this shopping center, if somebody was 10 kilometers away, somebody must be 10. If somebody had to be 10 kilometers, the person must live within this area. So if the criteria for the developer is that people should be 10 kilometers away, then means that this shopping center would cover people who are in this area. And you can then relate this also to your travel time. So buffers are useful for many reasons. Then in this case, you can see that if somebody was living in Craigie Bend, for example, and traveling at 60 kilometers per hour, it will take them more than 6 minutes to travel from Craigie Bend to this shopping center. But anybody within this buffer will be traveling at the same speed, constant speed, will be traveling around 6 minutes from their location to the shopping center. So that tells you the coverage in terms of travel time. Now, the second key function of buffers, particularly for this tutorial and for this course, is determining suitable locations for shopping centers. So let's say a new developer or new development. You want to find out which areas can you build your shopping center. One of the factors that will be considered would be, of course, existing competition. So you wouldn't want to develop a shopping center with the same range of services in close proximity to another shopping center. And by visual inspection, for example, if the developer's criteria is that I want to have a shopping center based on the range of services that we want to provide should be at least 5 kilometers from the nearest shopping center, then we will need to create buffers around all the shopping centers to determine which areas are suitable and which areas have great competition in terms of the concentration of existing shopping centers. So for example, if that is the criteria, you wouldn't want to put a shopping center here because this will be less than 5 kilometers from the nearest shopping center. To do that, you can of course create a buffer, but this time around, a buffer for all the shopping centers. So greater shopping center. This time around, no selected features. And let's say the criteria is that you want a space or a location that should be at least 5 kilometers from an existing shopping center. So we'll change this to 5. Now, since some of the shopping centers would intersect or overlap the 5 kilometer benchmark, we would select dissolve resolve, and then we click on run, then close. Now, what do we see here? That among other criteria, of course, including the availability of vacant land, but it means that if one of the criteria of a developer for choosing a site was that the location should be at least 5 kilometers from the nearest shopping center, then all of this region would be prone to intense competition. So it means that where is feasible would be locations outside of these places, and whether there's enough demand, um, um, availability of vacant land for development, and so on and so forth, would be additional criteria. But it means that judging on the existing competition of shopping centers, you can clearly see that these areas there is a close proximity to a shopping center, and therefore, if people are close to, they would may prefer to go to existing ones than you going to build a new shopping center there. So this is one way of uh, just measuring distances. But of course, there are other ways, and I'll demonstrate that as well. Of course, you could also create buffers for linear features, for example, roads or railways. And you could then even combine those buffers with this one to determine the locations that you can use. So, for example, you could add buffers to vacant land. If you have data on that vacant land, you can create buffers for linear features, for example, roads. Let's just do that pretty quickly. So our roads, let's check their properties. And if you come to information, you will notice that it's the unit is in geographic. So which means that if you wanted to create the buffers would be measured in degrees, which we are not interested in. So we need to, of course, the same process, project this into UTM. So let's save this as say roads, new. Okay, new. And let's say this would be roads UTM. And then we change our coding system to the UTM zone 55 south. Everything else remains the same, and then we click on OK. And we have now the roads UTM south. Let's move these down so that we can see what's going on. And then we have our roads. Let's give it a different color. To make it very clear, let's give it a red shade so that it's pretty obvious. So if another criteria was that the location should be, let's say, 2 kilometers away from the nearest main road or nearest major road, then we also need to create a buffer for the roads. The same process. Now, if you were interested in a particular location, of course, you could just select that particular portion of the road and also create your buffer based on selected features. But in this case, let's create a buffer for all the roads. So let's say buffer roads UTM, and let's say 2 kilometers. Sorry, and then run. Okay. Let's also add dissolve because some of the roads might be too pretty close, especially at the intersections. And let's say run. Let me drag this up. Now, what do we see here? That there are specific locations that could be of interest. That if you wanted a place to be at least close to 2 kilometers close to a major road, then these are the areas. These are the areas within the buffer. And if you combine, and this is how you do combine different requirements that you expect your development to meet or your site to meet before you choose in selecting a site for your development. You can combine different requirements. So, for example, we have done a buffer for the shopping centers, which should be at least 5 kilometers away from the closest shopping center. We've done for roads. We could keep on creating buffers, and then afterwards, you can combine all of these buffers to find out which sites would be the most suitable. And of course, you can add weights to this criteria. So whether the proximity to uh, a road is more important to you, or whether proximity to particular facilities, for example, whether existing parks is what is important to you, you can add all of that to your criteria, and you can use buffers to select the ideal locations that meet that criteria. So let me uncheck these buffers that we have created. Uh, For the demonstration, we do not need it anymore. I think we haven't saved our map yet, so let's just save it before we lose it. So let's say save as. I'm going to save it at the same location. And let's say tutorial. Save. Okay, now we can close these ones. So we've demonstrated how to do some basic measurements. There are other ways of doing basic measurements that we'll go on to, and that will be using uh, your distance matrix. And let's see how we can use distance matrix to also measure distances and export these distances to Excel or to a spreadsheet for further analysis. So the distance matrix works as follows. You want to measure straight line distances between an origin and various points of interest. So for example, there is a particular land use or facility that you are interested in. So let's say you wanted to find out relative to the shopping centers, how far away they are to Melbourne Central or Flinders Street. So let's find Flinders Street. Okay, Flinders Street is here, and let's select it. Now, if you also had another layer with different land uses, for example, you had schools, you had health facilities, you had, let's say, the institutions of governance, or anything that you wanted to measure distances from that particular land use or that particular feature to others, is exactly the same process. So here I've already selected my Flinders Street because I want to see the distribution of the shopping centers relative to Flinders Street. So having my Flinders Street selected, I come back to my vector and go to my research analysis tools. And then I click on distance metrics. So the input point layer is the layer that contains your starting point, the point from which you want to measure your distances. So you have your trains, unique IDs. So we can have our full IDs for the trains or train stations. I think train stations would be awesome. So let's say name. Let's just confirm that that is the case. So trains and open attribute table. Let's see whether the names are actually okay. So the names are actually the names of the train station. So that's correct. So we go back, vector analysis tools, distance matrix, and then selected features only. Input unique ID field would be name. And then our target, of course, would be our shopping centers. And the unique names or the shopping centers, we could use the, let's see. Yeah, let's use Q. I think Q is the names of the shopping centers themselves. Now leave, sorry, everything else as default. Uh, and leave this also as 0. So 0 means that it will calculate the distances to all the shopping centers in the layer. Everything remains default and you click on run. Then we can close this. And then we have our distance matrix here. Now let's see if we right click on distance matrix and go to attribute table. Let me minimize this a bit. So it gives us the distances from all the shopping centers from Flinders Street to all the shopping centers. And you can see that from here. So we have the closest on the Collins Street, and that's 278.87 meters. And the furthest is, let's scroll down, the furthest is almost 78,000 meters. So that's 78 kilometers. from Flinders Street. So this is how you measure the distances of all your features to a particular location of interest. Now you could also measure just instead of all the features or all the shopping centers, you want to find out which are the closest. Let's say the top 10 shopping centers closest to Flinders Street. To do that, we can uncheck this and go back to vector analysis tools, distance metrics. We would choose our trains as our starting point, import layer, selected features only. Unique ID would be name. Our targeted would be shopping centers. And in this case, what we're changing is here, use only the nearest key targeted points. So here you can say, okay, I want to find out the nearest 10 shopping centers to Flinders Street, the nearest 20 shopping centers to Flinders Street, and so on and so forth. So let's say the nearest 12 shopping centers to Flinders Street. And then we click on run. Finished. And we have here, if you right click and click on open attribute table, we have just the nearest 10 shopping centers to Flinders Street. Now these of course can then be exported. If you want, you can export these. So to export that, you can just click on the layer, right click and click on export and save features as. And here the format, you change it from ESRI shapefile to comma separated value. We can give it a name. So let's just save it in here. So let's say nearest shopping to Flinders and click on save. Everything else remains default. Yes. And then we click on add save. We don't need to add this to the map because we want to use this one for further processing. Then we can click on OK. Now this is saved. If we browse to the directory, you would find it here. So nearest shopping to Flinders Street, you can, if you open it up, of course you have our data here. So you have your distances, you have your targeted IDs. So these are your shopping centers, and then you have your input. So from Flinders Street. So between Flinders Street and all of these shopping centers, these are the distances, and you can then use this for your subsequent processing or analysis purposes. I don't need to save this. I can also close this. I can also uncheck this because I don't need this anymore. And then I also uncheck the selected. So this is how to measure distances, and I've demonstrated how to use your simple line measurements. You can also use buffers, and you can of course use your distance matrices. And the distance matrix always has a starting point and the reference in reference to all the other land use features or locations that you want to measure distances to. So let me bring the tutorial to a close, and then we can take a look at exporting the map in either JPEG or PNG or other formats that can be shared or printed in a subsequent tutorial.